There are the answers for Chapter 9 problems. Take a look. Hopefully you got them all right. If not, we'll work through them individually now. First, I want to point out a typo in question number 1, which is in the older versions of the book, but not the most recent print runs. Part B that says the PJX5. It's actually the RGM 7000. So hopefully that's not too confusing. Okay, so what we want to do is look at problems 1, 2, and 3 as a set. I split them up this way to show you the steps you go through to get your ultimate answer, which is what's the net present value of the project. Part number 1, we're going to come up with the cash flows. Do this the same way every time. We have some initial cash flow. We're going to have intermediate cash flows. In this case, it's going to be in years 1 through 14 because this is a 15-year project. And then we have some terminal cash flow in year 15. Sometimes special things happen in the last year. So in this case, it costs us $12 million to purchase and install the machine. So nothing else happens there. That's pretty straightforward. Now to find our operating cash flows. So once we get this machine running, what will it do for us? We need to go back to this formula: revenue minus cost minus depreciation. So the revenues will increase by $2,600,000 minus the cost, but here the costs are reduced, so you're subtracting a negative, which would be a positive. The other way to think about this, you're reducing your cost by $500,000. Reducing your cost is like adding money. Now subtract depreciation. Well, what's depreciation? We're always going to use straight line depreciation because it's easier. In the real world, you would use whatever is appropriate, but we don't want to get bogged down with calculating depreciation, so we do it the easiest way possible. You have the cost of the equipment fully installed minus the salvage value. In this case, it says we're going to fully depreciate it and remove it at no cost or no value, and it's over a 15-year life, so that's $800,000 in depreciation. At this point, we take out our taxes, 1 minus the tax rate, and then add our depreciation back. That is equal to $2,180,000. So our intermediate cash flow is $2,180,000. Our terminal cash flow is $2,180,000 plus nothing else is going on, so we leave it there. It's that simple. Question number 2, by the way, question number 1 asks for the internal rate of return. And I ask for it at this point because I can find the internal rate of return with just the cash flows. The answer is going to be 16.274%. You can look at page 183, I believe it is, to see the steps that you would go through to put this in your calculator. But what you do in kind of short terms is cash flow 0 is the minus 12 million. Cash flows 1 through 15. Well, in this case, the calculator just wants to see cash flow 1, which is the $2,180,000. And the frequency of those cash flows, you tell the calculator that happens 15 times, because this happens 15 times, right? Then we press IRR and then compute, and it should give you that answer. To get the net present value, we need the weighted average cost of capital. So question number 2 says, what's the weighted average cost of capital? We know it's equal to the weight in equity times the cost of equity plus the weight in debt times the cost of debt, and we know that debt has a tax advantage, so we can multiply by 1 minus the tax rate. The capital structure is given in part A, and that's how much of the money you raise. So I got to raise $12 million to do this. 65% of that money comes from equity, and 35% of that money comes from debt. Now, what's my cost? Let's start with cost of equity. What's my cost of equity? I can go to part C. I remember from chapter 7 that the price of a stock is equal to the dividend the next year divided by K minus G. If that stock has constant growth, that K is the cost of equity that we find right here. So KE is equal to D1 over P0 plus G, which in this case is 2, and read carefully, this is a dividend next year, so this is in fact D1 over P0, which is 25 plus 0.05, so that's equal to 13%, so I put in my 0.13 right here. My cost of debt, the cost of debt over here, I know from chapter 6 how to find yield to maturity. Well, yield to maturity is the cost of debt. So it says it's a 10-year semi-annual pay, so n's equal to 20, 5% coupon, so the payment, and we always assume $1,000 unless the problem tells us different for the future value, for the face value or the maturity value, par value. So 5% of 1,000 is 50 divided by 2 because it pays semi-annually is 25. The par value is 1,000. That's my payout rule. I know that people are paying $990 for that, so minus 990, not 900, minus 990. I plug this into my calculator. It gives me an interest rate equal to 2.5645%. But I need to multiply this by 2 to come up with my cost of debt. I'll multiply that by 2, and now I have this, of course, in decimal form. It comes out to be 5.1291%, multiplied by 1 minus my tax rate, 0.4, and this will give me a cost of capital, weighted average cost of capital, 0.09527. So now to answer question number 3, and I'm going to put 3 right here. I already have my cash flows in, so I need to put in my cash flows the exact same way right here because they're the same cash flows. And then I press the net present value button. I put in 9.527, put it in this form, not in decimal form, as my interest rate. Enter, down, compute, and the net present value is going to be 5,038,602.94. Okay, so now I want to go back through and look at what if the tax rate were 45%. So what if the tax rate were 45% and not 40%? So first of all, right here, remember this was 1 minus 0.4. So if I go through and make these changes, I'll do that in red. This will be 1 minus 0.45. You'll change this cash flow to be 2,065,000. So those cash flows change to that 2,065,000. The internal rate of return will change to 15.129%. Why did that go down? The government's taking a bigger chunk of your money, so they're a larger partner now. So the internal rate of return is going to go down because it makes the cash flows go down. Because the cash flows go down, it's going to make the net present value go down. This is going to stay the same. Well, no, this is not going to stay the same. This is going to change as well. You're going to have this to be 0.45, and I didn't write down the weighted average cost of capital here. Oh yeah, I did. It's going to be 9.437%, and this is going to change then the net present value to be 4,224,141.07. Okay, now I want to do 1 through 3 over with a twist. So what if I said the cost increase, not the cost reduce, but cost increase? How would that change the problem? What I would have is my operating cash flows would be the 2,600,000 minus the 500,000 minus the $800,000 depreciation, 1 minus the tax rate of 0.4 plus 800,000. So in doing that, my operating cash flows are 1,580,000. So it's exactly the same as before, except if the cost increase, it makes this negative. So I just want you to have a little extra practice here. Internal rate of return would be 10.026%. You would still have the initial cash flow is minus 12 million. These are cash flows 1 through 15. The net present value, you would use the same 9.527% weighted average cost of capital. The net present value would be 349,079.19. Okay, if you want a little bit more practice, well, if I change this to 0.45, then my cash flows are going to come out to be 1,515,000. My weighted average cost of capital is going to be 9.437%. My net present value is going to be minus 97,058.73. My internal rate of return is going to be 9.298%. So a few little comments here. Remember, this is if the costs increase, and in blue we have what happens if the tax rate is 40%, and the weighted average cost of capital was the 9.527%. So you go back to part B, the same weighted average cost of capital. The only thing that changes now is these intermediate cash flows. That gives me an internal rate of return of 10. I know I will accept the project. I know net present value will be positive because the internal rate of return is greater than the cost of capital. If I increase the tax rate to 45%, the government's now taking a bigger chunk of your earnings. It's taking a bigger bite of your money machine, so it reduces your cash flows to this number. The weighted average cost of capital goes down because you get a bigger tax break when you do the depreciation. And then this is going to cause, because the government's taking a bigger bite, it causes my net present value to be negative. I know if my net present value is negative, my internal rate of return is smaller than this number, which is true. So if you get these 1 through 3, this is kind of the base case of Chapter 9, and I think you're starting off with a pretty good grasp of what we want to do in the additional problems.